Hi everyone, we are from Team TNG and let me introduce to our members Nicholas Cho as our leader and other two members Grace Ling and Wan Ki. We are grateful to have this opportunity to participate in this program, Malaysia Green Innovation Carnival 2023 Green Renewable Energy. We are now presenting our innovation solution on solving the environmental issue faced by the public. The Sustainable Development Goal (SDG) involved in our innovation is SDG 12, which is the responsible consumption and production. Nowadays, the plastic consumption in whole world is being increased, whereby the plastic waste also being increased and lead to environment pollution, especially the microplastic pollution in the ocean. In our innovation, we came up with an environmental friendly solution to reduce the microplastic pollution and plastic waste. Also, we turn the byproducts that produced during the biodegradation of plastics into other useful products. At the same time, we really hope that the society can increase their awareness towards the applications of heavy plastic usage on environment and human health. The solution that we came up with was focusing on polypropylene plastic, which is PP plastic. The reason of choosing PP plastics is based on results of a survey conducted by us within a few weeks at a hostel in our university. We found that PP plastics take up the largest proportion of consumer plastic consumption. After research, we found that PP plastic takes a long period of time to completely break down in landfills, which take approximately 20 to 30 years. And we also found that PP plastic is one of the plastics that are difficult to recycle compared to other types of plastics like low-density polyethylene plastic, LDPE plastic. These plastics will end up degrading into a huge amount of microplastic over the next 400 years. Therefore, our solution is using a type of bacteria, namely Lysinibacillus, to undergo biodegradation of polypropylene plastic.
Hi, my name is Grace and I will be presenting the description for our solution to alleviate microplastic pollution. Firstly, let me introduce our most crucial role in this solution, which is the bacteria itself. The bacteria used in this solution is Lysinibacillus sp, and it is a newly classified genus that was referred as Bacillus last time. This type of bacteria is usually obtained from the soil. It secretes organic acids, hydrolytic enzymes, and metal chelator compounds that enable the conversion of insoluble minerals into bioavailable form. To cultivate the strains, the nutrient medium needs to be kept at 30 degrees Celsius for 2 days with shaking at 200 revolutions per minute. Next, I will talk about how we prepare Lysinibacillus sp for biodegradation. The soil used for the biodegradation will be treated with kineplastic complex. This is because kineplastic complex can increase the biodegradability rate of plastic and hence shorten the time for biodegradation. Then, Lysinibacillus sp and Luria bertani medium will be added into the treated soil to be mixed together for the biodegradation process. Luria bertani acts as a nutrient base for Lysinibacillus. Since Lysinibacillus secretes enzymes like lipase or dehydrogenase, PP, which is polypropylene plastic, will be degraded into mainly carbon dioxide and hydrogen gases as the equation shown in this slide. To carry out this biodegradation in a larger scale, there are a few steps that need to be executed. Firstly, shipping containers are used for biodegradation. Next, the soil treated with kineplastic complex is added, followed by Luria bertani medium and Lysinibacillus sp. The PP plastics collected are processed into small pieces beforehand. After that, the soil plastics and Lysinibacillus sp are mixed together using a stirrer. Throughout the biodegradation process, carbon dioxide and hydrogen gases are released. These gases are collected and transferred to a reactor plant through underground pipes for further hydrogenation process. To make sure that the rate of the process is always at the optimum, the temperature is kept at 30 degrees Celsius and pH at 7 using temperature controller and pH controller respectively. Water is added from time to time for moisture. Also, feeding solution, which consists of 1% glucose and 1% yeast extract, is added every 2 days to ensure the growth of Lysinibacillus sp. The bacteria itself is added every 4 days too for consistency of the process.
Alright, thanks Grace. Now I will give a brief evaluation of our solution. Firstly, to simplify the evaluation of our solution, we have made a few assumptions. We assume that all plastics fed to the biodegrader will degrade completely. We also limited the factors affecting the rate of degradation to pH and temperature only. Therefore, the efficiency should stay the same even when scaled up to an industrial scale. In order to achieve our aim of responsible consumption and production, here is what our solution can potentially contribute towards sustainability. Firstly, this solution is much more environmentally friendly compared to the traditional way of eliminating plastics through incineration. The incineration of plastics not only produces carbon dioxide but also toxic gases such as mercury, dioxins, and more, which are detrimental to the environment and human health. By implementing this solution, the release of toxic gases can be avoided, as biodegradation of plastics only releases carbon dioxide and hydrogen gases. Secondly, the closed environment where the bacterium works to decompose the plastic prevents harmful microplastics from invading the ecosystem. Traditional disposal methods in landfills allow naturally decomposing plastics to enter the soil and groundwater, causing microplastic pollution. Therefore, the solution can prevent any further additions of microplastics into our ecosystem. However, we also realize that the biodegradation of plastics using bacteria will result in a large amount of CO2 produced. Therefore, we also suggest adding a catalytic converter to convert produced CO2 into methanol, using the hydrogen produced during the biodegradation. This methanol can then be used as a substitute to fuel. That's it for our presentation, and thank you for your attention.